everyone. I am Shooka Motamedi. I am a researcher and a lecturer at the Christopher C. Gibbs College of Architecture in the University of Oklahoma. Leveraging neuroscience as a tool to advance architecture pedagogy is an article that I would like to discuss with you today. I've been working over architectural researches in the last 5 years, and most of the things I was doing was using neuroscience as a tool to learn more about the possibilities of architecture and knowing about people's brain and how they perceive the space. But recently, I just realized that how interesting it might be to consider neuroscience in the pedagogy of architecture, as well as using it in a profession as a tool to know what the design ideas should be, but even before that, to teach architects how to think that way and how to make the design studios more diverse according to the people's brain and learning about its potentials. So what I'm going to cover in this study is the interaction of neuroscience and educational sciences. I will talk a little bit about mind-brain education, cognitive psychology, schema and its role, learning and memory. I will hint a little bit to the evidence-based education and the methods which are more compatible with the brain, which we call them brain-compatible educational methods. And then I will review some techniques on how it might be possible to bring it to the architectural studios. As the architectural design studio culture is based on old-century traditions, it should be rethought. The students of today can't be treated as older generations, and they have their own needs and demands. The brain of the people will change over time, and people become alters through their historic experiences. Especially cybernetic era has changed human brain drastically, and the presence of different social media as well as multimedia revolution have had a high impact on the way people learn. Taking a look at Marist's mindset to 2026 school proves that why we need to learn again about today's unique learners. Envisioning inclusive learning environments which consider equity and inclusion as the optimal learning environment, emphasize the needs for diversifying pedagogical approaches. So in this research, I will investigate the relationship between cognitive neuroscience and education and learning, and neuroscience's impact on psychology, cognitive neuroscience, evolutionary cognitive psychology, social cognition, and social neuroscience, and the application of neuroscience in the field of educational science. And the aim is to use neuroscience for advancing pedagogy in the architecture field and diversifying the discipline, methods, and studio culture by considering individuals' brain. So there is this effective interaction between neuroscience and educational science in improving theory, thinking, practice in the field of teaching and learning science. All sensory, intellectual, emotional, and intuitive perceptions occur in the brain. Therefore, neuroscience could be a reliable tool to hold to for directly finding what is happening in the learner's mind and how we can enhance our teaching methods and techniques to meet everyday students' ways of learning and consider all learners without exception. Neuroscience tools and techniques help understand the process of knowledge, insight, and experience. Cognitive neuroscience can elevate classroom instructions. Mind-brain education is a joint chapter of neuroscience and educational science. And there's a gap here. There is a disconnection between scientific knowledge and practical applications in the classrooms, while not much has been done regarding the architectural education. And there is a need for evidence-based approach. The abstract concepts of neuroscience and educational science and the epistemological differences between their explanatory and scientific theories makes this huge gap between what we actually do in our architectural studios and what can really happen by considering the mind, brain, and education. And it's mostly about the cost and time, and maybe about the knowledge, which this research hopes to draw the attention to it. To understand how teachers can change the brain, we need to begin with a reasonably new understanding of the biology of learning. The human brain is an experience-dependent experience. Through our lives, the cerebrum, the largest portion of our brain, finds human itself to adapt to the world around us. The scientific term used to describe this is neuroplasticity, which involves 3 different processes of proliferation, pruning, and consolidation. And through all of these processes, we see that how a brain can change by teaching and how teachers can influence people in having altered brains. By focusing on cognitive psychology, we will see that schema has a great role in that. While the practice of architecture has adopted in response to some innovation, from new building materials to computer-aided design, its core pedagogical theories remain parked in the past, neglecting recent significant insights the biological sciences have delivered about the human conditions and how we function. Our cognitive schemas and processes are influenced in some way by cultural and social indicators that play a decisive role in shaping, processing, and transforming schemas. The formation of a schema is an important part of the student's learning process in which the individual's mental models of the subject are structured. The relationship of previous learning with new learning that has emerged from cognitive psychology can influence the learning process. Professors with a deep understanding of these theories can choose the best teaching learning method, a mental model or schema, which is a kind of cognitive representation of a part of a system. The cause and effect relationship shows how a change in one part affects another. Architectural design educators of the false premise in their core thinking that the mind is a blank slate, and we used to call it tabula rasa. This is not the case. Humans enter the world hardwired to respond to specific patterns in very specific ways. This is something that in many professions they have put attention to. Car maker, advertisers, computer scientists all know this. It's time for architects to learn biological reality too. The appropriateness of learning conditions to the type of sensory input related to the subject being learned reinforces learning, meaning that because the sensory stimulus and the subject matter are relevant to the individual's previous experiences, there is a logical relationship. Hence, it is tangible that creating a schema will facilitate learning. For example, when giving a speech, the use of nonverbal skills by the speakers creates a kind of multisensory interaction. Enhancing the content of a speech with body postures causes the formation of perceptual representation in the premotor cortex of the listener. This homogeneity links auditory conceptual perception and the body movements, proportionate hand movements, resulting in more and better understanding, representation, and learning. So It's a good idea to learn more about the memory and how it functions. And it's possible through different devices which neuroscience can offer us. Some of them, they have to be done in huge labs, and they need more facilities, and some others can be even used in the classrooms. EEG, like parametric data we can get from the galvanic responses. There are also neuroimaging studies, PETs, ERP, MEG, which they will all tell about what's going on in the brain and how memory can be triggered for helping advancing the teaching. Evidence-based design has been around for years in the healthcare industry. It's a technique used in the process of designing the spaces people typically go to feel better. Though a school building, an architectural studio is not the place most people come to heal, there are ways to create an educational space that will make it feel as such. Education, health, and satisfaction improve significantly when using the design techniques research has given us. We now have incontrovertible biological evidence that the built environment affects humans, both mentally and physically. We can track it, we can deliver hard data and measure down to cortisol levels how different built environments engender biochemical changes in our bodies and can harm human health, both mentally and physically. This means we can no longer teach future architects that the abstract party is the unique central organizing feature of design. We need to put people and biology and human functions at the center of their thinking. The limitation no longer holds us back. The explosion of scientific and tech innovation has produced a battery of new biometric tools for uncovering the thoughts, feelings, and emotional responses people have to build conditions. This evidence can no longer be ignored by architectural educators. Architects today face a unique opportunity to reshape the environment, so it's a better fit with our biological nature. They are in an unprecedented position to use evidence-based design and build what people want to unconsciously see and be in. With new biometric tools, they can more easily do post-occupancy evaluation, asking people where they feel at their best, ensuring that new projects are rooted in successful precedents for real. Brain-compatible educational methods help us know about individuals' skills, potentials, and preferences. Effects of nutrition and sleep, working hours, gender, age, individual differences in anything, even in the time of sleeping. If we consider emotions as the central nervous system, we have to cover that we have two kinds of tissues, gray matter and white matter. And this matter seems to be at the heart of many gender differences. Male brains contain about 6.5 times more gray matter, and female brains have approximately 9.5 times more white matter. Gray matter contains the dendrites and synapses, and boys' brains are primarily associated with processing and cognitions. White matter is made of axons which act as a relay, coordinating communication between different brain regions. The skills are often better at connecting feelings with thoughts and words, with a higher density of neural connections into the hippocampus. Girls can absorb more sensorial and emotive information than boys can. In other words, girls tend to sense more of what is going on around them and are faster and more accurate at identifying emotion. Boys can have trouble picking up an emotional cues unless they're clearly verbalized. The hippocampus, our human memory center, is often larger in females, and they also have more natural blood flow in the part of the brain that holds emotional memories. But boys generally have a larger inferior parietal lobe, which controls numerical brain functions. According to a recent study, this area of the brain matures about 4 years earlier in boys than in girls, leading to superiority in math and geometry, at least temporarily. The parietal region is also thicker in the female brain, making it harder for girls to mentally rotate objects or envision a setting in 3D. Girls' challenges with these important and special skills play into their physiological disadvantages in geometry, as well as their ability to perform activities like navigating. Boys use mainly the left hippocampus for navigation, which automatically codes where they are in the space. So as we see, there are more of these type of examples, but just considering that how just the gender can change everything in the matter of learning, we can make our studios more diverse by considering how people learn. And also, there might be some strategies that the instructors might want to use. In the case of architecture, for example, team working and then separating the students into boys and girls for some specific assignments helps them to use each other's potentials, although these are not completely accurate and it differs from person to person finally. Or for example, it's different for the working hours. Some people feel better in the morning, some people feel better in the afternoon. And why does our studios have to be always in one specific time? What if we could offer them a more diverse time and hours so that everyone could feel the best when attending a studio class? So there are several different methods and techniques that we can approach for having more diverse and better experiences in our architectural studios. In teaching architecture, the active processing of experiences and the brain interaction with the environment and the growth of neural networks can be a good basis for designing brain-compatible trainings. One of the very good ways to do that is to motivate learning in the learner and facilitating it. By you being, as an instructor, enthusiastic, vary teaching methods, strengthening students' self-confidences, and creating a learning environment free of stress, but with a degree of difficulty and a pleasant challenge. Like, for example, in what you see in these photos, this is our studio for the last semester. Our students are having a very hard task going on, and they have a charrette. But as you see, they have their hammocks on the ceilings. We just let them feel at ease and feel at home and do it the way they want it, but still it's a hard task going on there. Enthusiasm and passion are contagious. Your positive energy leads to the students becoming more motivated, as a positive attitude is a must for a successful learning atmosphere. So being enthusiastic is very important. Praise builds the students' self-confidence, competence, and self-esteem. Recent research in neuroscience has shown that receiving sincere praise activates the same areas in our brain that are activated when we receive money or romantic attention. The ventral striatum and the ventral medial prefrontal cortex, it is also said to release the neurotransmitter dopamine, which is associated with motivation, focus, and positivity. In other words, it activates the reward circuit in our brain. Paying attention to using multimedia training to stimulate multiple senses. These days, most of the schools provide many of these, like smart boards, like Miro boards, 3D printers. The students have iPads. Bringing more of VR sunglasses, touchable holograms, and metaverse are also some opportunities that we can see for enhancing the teaching and learning of the architecture in our architectural studios. Diversifying the design studio environment by incorporating all potential learners with various talents according to their respective skill sets. Some of the students are coming with different abilities, like ADHD, like some of them are, like in my experience this semester, I have 2 ADHD students and 1 colorblind students, which we cannot exclude them, but we need to find ways to keep them on track and letting them enjoy their work. I use the same strategy for my colorblind students, which I made a team with one of the students that they were really enjoying this assignment, going out in the nature, picking up things and telling each other about their different points of view, that what the actual color is. And finally, the results of the board was fantastic, because my student with the color problem, he was very good at textures, and the outcome was really great. Also, for some of the ADHD students, we can come up with some strategies. Like, for example, I came up with giving them small deadlines within 1 single day in order to focus, or letting them to listen to music or whatever makes them feel better. Involving the students in the teaching learning process and using their experiences. Student engagement triggers neurochemical changes in the brain. As we learn, these dendrites grow and we build an increasing... Yes.
You need to conclude within a couple of minutes.
Okay. So yes, I will move on faster. As a conclusion, becoming familiar with the brain change, as the use of technology and computer is changing our brains, it's essential to become more familiar with the ways this technology alter our brains. Teachers, as the brain changers, can promote deep learning by building on the students' prior knowledge, and that knowledge base provides the foundation for deeper understanding and transference. In this regard, neuroscience can be helpful for an architecture career in 2 ways. First, helps to educate future architects according to their capacities and based on new computer technologies which have evolved the learning and the capabilities of today's learners. Second, it helps future architects find the mentality that they should design according to the affects, needs, and desires of the today's human mind. Cognitive psychology is essential in creating a conceptual connection between neuroscience findings and architectural education. Teachers need to be aware of what the students are learning and how they're learning. This principle is the basis of evidence-based education that strengthens the connection between learning and strategies for its improvement through basic and applied studies. Since the formation of a schema plays a pivotal role in the active learning of students, studying this topic can be a research priority. Recent studies in neuropsychology emphasize multimedia education. Examining such homogeneity determines whether the combination of inputs of different sensory aspects can be institutionalized in the form of a schema. To understand the brain processing and neural circuit involved in the learning, it is necessary to be aware of theories related to learning and memory from the perspective of neuroscience. To enter the field of neuroscience studies and teaching learning science, and especially architecture education, it is necessary to form interdisciplinary working groups that include at least specialists in neuroscience, architecture, educational science, and cognitive psychology. Instead of just trying to continue what already exists as evidence-based learning sciences, we can think of defining a new branch of research, including the mind, brain, and education. And thank you very much for your consideration, and sorry for keeping it too long.